So ladies, what we're going to do is we're going to talk about limiting reagents. Now, right now we're in the section in chemistry where we're dealing a lot with chemical reactions, but also like numbers, right? Trying to predict the numbers, the amount of, the mass of reactants and products. That branch of science is called stoichiometry, where we're looking at reactions and trying to predict, based on molar ratios, trying to predict the mass of things. So today we're going to look at 3 sample questions that have to do with limiting reagents or limiting reactants, okay? So here's the first question. We have 5 grams of calcium hydroxide that will react with 3 grams of hydrochloric acid to produce water and calcium chloride, all right? So what is the first thing you should do? Well, before we even get to that, what's the first thing we should do? Yeah, let's write out the equation, okay? So, calcium hydroxide, Lauren. What's hydroxide's formula in charge? So then, calcium hydroxide is this, Ca bracket OH bracket 2. And that reacts with hydrochloric acid. And that's going to give you calcium chloride and water. Okay. Is it balanced? No? Okay, so let's balance it. So we're going to put a 2 here and a 2 here, and now it should be balanced. All right. Now, so first step is write the equation out and then balance it out, which is one of the things that we've learned, right? Okay. Now, we have, in this question, we have 2 things. We have the mass of the calcium hydroxide, and we have the mass of the hydrochloric acid. Now, normally when we talk about acids, we talk about concentrations and volume, but I'm going to keep this simple. I'm going to give you the mass of the acid. We'll talk about concentrations and volume in the next unit when we do solutions, okay? So we have 5 grams of calcium hydroxide, we have 3 grams of hydrochloric acid. So let's figure out now how many moles that represents. Okay? So how many moles is 5 grams of calcium hydroxide? Remember, number of moles is mass over molar mass. Now, calcium hydroxide is, so on the side, I'll just do it here. Calcium hydroxide would be 1 calcium atom, and then it would be 2 oxygen and 2 hydrogen. Calcium weighs about 40, oxygen weighs about 16, and hydrogen weighs about 1. So what is that? 40 plus 32, 72, so it's about 73. So the molar mass of calcium hydroxide is about 73, okay? So 73 grams per mole. So how many moles is that? What's 5 over 73? Zero point zero six eight. Thanks, Sarah. Moles. Okay, so now we know how many moles of calcium hydroxide. We're told we have 3 grams of hydrochloric acid, right? So 3 grams is how many moles? So again, it's the mass over the molar mass. Now HCl is 1 hydrogen, which is 1, and 1 chlorine, which is 35.45. So that adds up to 36.45. How many moles is HCl? 3 over 36 is like 1/12. So it should be about 0.08. What is it exactly? Yep. Okay, so 0.082. Yep, plus 1 hydrogen, right? It's HCl, so 1 hydrogen plus 1 chlorine. Okay. Now, the molar ratio is 1 to 2, correct? So if you look at the molar ratio of calcium hydroxide to HCl, it's 1 to 2. So if we have 0.068 moles of calcium hydroxide, how many moles of HCl would you need? Well, you would need, the ratio is 1 to 2, and you solve for x, you're going to find that x is actually 0.136. You solve for x, x is going to be 0.136. Now, that's how many moles of HCl you would need. Do you have that many moles of HCl? No. So when it comes to limiting reactants, the one that you have too much of is not your limiting reactant, or the one you don't have enough of is your limiting reactant. So in this case here, we need 0.136 moles of HCl. But we only have 0.082 moles of HCl. So then what's the limiting reactant? It's the HCl. We don't have enough of this. This is my limiting reactant. Okay? The ratio says I need 0.136. The information says we only have 0.082. Therefore, that's my limiting reactant. Okay. So now we know what our limiting reactant is. We know it's the hydrochloric acid. So if I was to write this out, I'm just going to rewrite it and say CaOH2 plus 2HCl gives me CaCl2 plus 2H2O. We know now that it's going to be HCl, that's the limiting reactant. So we're going to use up all of it. So then how many moles of calcium hydroxide would react with that? Well, if the ratio is 1 to 2, then this should be exactly half. This should be 0.041 moles. So 0.041 is exactly 1/2 of 0.082. Do we have more than 0.041 moles of calcium hydroxide? Yeah. So you can see right here, we have more. Remember, calcium hydroxide is not the limiting reagent, so we have more of it. Okay. Now, your calcium chloride, how many moles of calcium chloride would you make, theoretically? The ratio of calcium hydroxide to calcium chloride is 1 to 1. So if I use up 0.041, I should get 0.041 moles of calcium chloride. The ratio of HCl to H2O is 2 to 2, so it's the same. So if I use up 0.082 moles of HCl, I should get 0.082 moles of water. What do you think? Does it make sense so far? So let's figure how much that is. We know we use up all of the HCl because that was the limiting reactant, right? And that was 3.0 grams. Now, how many grams of calcium hydroxide? How many grams of calcium chloride? And how many grams of water do we use up or produce? So let's think about calcium hydroxide, right? How much calcium hydroxide do we use up? So we're going to just rearrange this formula. Number of moles is mass over molar mass, and we're going to look for little m. So little m is N times big M. So how much calcium hydroxide do we use up? Well, we know it's 0.041 moles. And the molar mass of calcium hydroxide was 73. So what's the mass of calcium hydroxide? So what's 0.041 times 73? That sounds about right. So we'll just say 3 grams. Round it up to 3 grams. So 3 grams. Okay. For calcium chloride, what's the mass of calcium chloride? Well, again, number of moles times the molar mass. Number of moles is 0.041. The molar mass of calcium chloride, calcium is 40. 2 chlorine is about 71. So 71 plus 40 is 111. So what's that? Should be like 4.5 grams. Okay. So now we have the mass of 2 reactants and 1 product. Now for the final product, you could use the law of conservation of mass, because that has to be the difference. So on the left side, what's the mass of the reactants? 6, right? Because it's 3 and 3. So 3 and 3. So that's 6. On the right side, it's 4.5 and Z. Z has to be 1.5. It's a Z, sorry. But let's calculate it, okay? Let's work it out. What is M? M is N times big M. It's N is 0.082 times the molar mass of water. Water is 18. So what's 0.082 times 18? Okay, 1.476, so 1.48. Now, we predicted 1.5, we got 1.48. If you rounded it off, that would be 1.5, so that's correct. Okay? So if we round this off to 1 decimal place, it would be 1.5. There's your answer. The right side now equals left side. Okay? So that's one example. So far, so good? So, what do you gotta do? You gotta write the equation out, balance it, you gotta think number of moles. You have to think number of moles, okay? Very important theme there. Okay, let's look at the second question. So here's a different reaction. Very similar, yeah. But in a test, you don't have to worry about limiting reactants, right? The other reactant was excess. So in this case here, we have 10 grams of aluminum and 2 grams of copper 2 chloride. So 20, just so you're paying attention. What's the reaction? So it's what? Al plus Cu later. CuCl2. And that's going to be AlCl3 plus Cu never. Okay. So, balance it out. You're going to need okay. So we have the molar ratios now for aluminum, copper 2 chloride, aluminum chloride, and copper. So now again, think in terms of now moles, right? We have, it says 10 grams of aluminum. So how many moles is 10 grams of aluminum? So number of moles is mass, 10 over molar mass. So aluminum is about 27. So how many moles is that? What's 10 over 27? Should be like a little bit more than 0.3 something. 0.37? Yeah. It should be 3, yeah. Just seeing if you're paying attention. Should be 3. Thank you. Thank you, sir, for clarifying that. Alright, now, 20 grams of copper 2 chloride. So how many moles is 20 grams of copper 2 chloride? Mass over molar mass. Copper is, what's the molar mass of copper? Actually, let's work it out over here. So it's 1 copper. How much? Sorry, what was that? 63 point? and it's 2 chlorine at 35.45. So what's the sum of that? 63.55 plus 2 times 35.45. 134. Let's round it off. 0.5. Okay, so its molar mass is about 134.5. Yep.
But you said even numbers and round up and
Round up to 0.4. So we keep, okay, so we do proper rounding, you're right. So, okay, number of moles. How many moles does that represent? 20 grams over 134.4. 0.14888, so I'm going to round this off to 0.15. So 0.15. Okay, now we got to figure out what's the limiting reagent. So we're going to look at the ratio of aluminum to copper to chloride. The formula says the ratio should be 2 to what? 2 to 3. So let's say we go with the aluminum. So aluminum is 0.37. How many moles of copper to chloride would we need? So we're going to solve for x, okay? So if we solve for x, x would be 3 times 0.37 over 2. X is, what is x? 0.6? 0.56. So we need 0.56 moles of copper 2 chloride. We don't have that. So that means this is the limiting reagent, the one that we don't have enough of. So now what we're going to do is we're going to rewrite the formula and think about how many moles. So we have, so it's 2 aluminum plus 3 copper 2 chloride gives us 2 aluminum chloride plus 3 copper. The limiting reagent was which one? Copper 2 chloride at 0.15 moles. Okay, so then how many moles of aluminum do we use up? We don't use all of this up, 0.37. We only use some of it up. So now we could set it up the exact same way as we did over here. So instead of looking for the number of moles of copper 2 chloride, we look for the number of moles of aluminum. We know we're going to use up 0.15 moles of copper 2 chloride. Sorry, So we're looking for the number of moles of aluminum. So we know we're going to use up 0.015 moles of copper 2 chloride. Let's solve for how many moles of aluminum we actually need. So we're going to solve for number of moles of aluminum. The ratio is 2 to 3, right? So think numbers. Instead of thinking this as 0.15, think of it as 15. What would 2/3 of 15 be? It would be 10. So that means that you would need 0.1 moles of aluminum. Because 0.1 is exactly 2/3 of 0.15. Now we have the molar ratios for all our reactants and products. So how many moles of aluminum chloride do you make? 0.1. And how many moles of copper do you release? 0.15. All right. Now, the copper 2 chloride was the limiting reagent, right? So how many grams of copper 2 chloride did we use up in this reaction? We don't have to calculate. I think we were already told what it was. What was it? In the question above. It was 20. So we know that this is already 20. But now we're going to solve for x, y, and Z. You don't have to use the terms X, Y, and Z. Okay. All right, so let's solve for the reactants and the products. Okay, so how many grams of aluminum? So it's 0.1 moles. Aluminum has a molar mass of 27, so that would be about 2.7 grams. So on the left side, we have 20 grams, 20.0 grams, and 2.7. So on the left side, we have 22.7 grams. What should the right side be then? 22.7 grams. So let's work out Y, which is aluminum chloride. What's the mass of aluminum chloride? Number of moles times molar mass. 0.1 times the molar mass. So aluminum chloride would be 3 chlorine at 35.45 plus 1 aluminum at 27. So what's the molar mass of aluminum chloride? Sorry, 100 and? Okay. So how many? So that would represent 13.3 grams. If I just leave it to one decimal place. Now, again, copper we can figure it out two ways now. It's either the difference or we can actually calculate it. So let's calculate it. So M equals number of moles times mass, molar mass. 0.15 times, copper was what, 63.55 you said? Okay, so what, that should be about, should be close to 9. 9.5. Yeah, should be 9.5. The right side equals 22.8. The left side equals 22.7. The slight difference is due to rounding. Okay? But this is how you would solve it. We'll do one last question, then we're done. Alright? And the last question I will look at is all the same concepts.
Oh, look, Lord, I hate hydroxide now.
So here, another hydroxide question. Give me the mass of the reactants and products in the following reaction. Iron 3 sulfate and potassium hydroxide. Again, first thing you do is you write out the balanced equation. So iron 3 sulfate would be Fe, and sulfate is what? SO4. Sulfate in order is minus 2. Iron is plus 3. So how many sulfate do you need? 3 and 2 iron. And that reacts with potassium hydroxide, KOH, and that gives us potassium. What kind of reaction do you think this is going to be, by the way? 2 compounds. What kind of reaction do you think this is going to be? Double displacement. So potassium sulfate and iron 3 hydroxide. Okay. Now, balance it out. This is one we actually did before. Well, yeah. From what I remember, you need 6 of these. And you need 3 of those. And 2 of those. And I think it's balanced. Yeah, it should be balanced. Yeah, it's balanced. Okay. Alright. Now, again, we have our mass. So we have 1.5 grams of iron. So how many moles is 1.5 grams of iron? So it's mass over molar mass is 1.5 over the molar mass of iron 3 sulfate. So iron 3 sulfate would be 2 iron, 3 sulfur, 12 oxygen. Oxygen is 16. Sulfur is about 32. What's iron? Don't say hard. I know that. What's what is it?
55.5.
Wow.
That's so salty.
Very salty. Actually, 55.8. Okay. So what's the molar mass of iron 3 sulfate? 2 times 55.8 plus 3 times 32 plus 12 times 16 adds up to? Since we're go. Or you could just Google it. If you ask Google, it'll tell you. What is it? All right. Shall we? 399.6. Okay. So it's about 399.6. Let's just round it up to 400. So how many moles is that? I rounded it up to 400. So how many moles is that? 1.5 over about 400. 0.0038. All right, let's look at the number of moles of potassium hydroxide. So we use 2.5 grams. Potassium hydroxide is 1 potassium and 1 oxygen and 1 hydrogen. Hydrogen is 1. Oxygen is 16. That's 17. Potassium is 39. So it's 17 plus 39 is about 56. So how many moles is 2.5 grams of potassium hydroxide? 0.046. Okay. Now, 446. So we'll just say 445. So we'll just say, leave it up. That's fine. Okay, how many moles then? So which one's the linear reaction? Again, with the same thing. So let's look at the molar ratio. Iron 3 sulfate relative to potassium hydroxide. The ratio is 1 to 6. So how many moles of iron 3 sulfate would you need if you have 0.045 moles of potassium hydroxide? So we solve for X. So X would be 0.045 over 6, which adds up equals what? 0.0075. So, do we have enough of that? No. So then what is the limiting reactant or reagent? Yep, this is the limiting reagent. We have 0.0038 moles. We need 0.0075. We don't have enough of it. So that's the limiting reagent. So I'm going to rewrite the equation. Okay, so I'm going to rewrite it so we can fit everything. Okay. So we worked out the limiting reagent, right? It was iron 3 sulfate. How many moles of potassium hydroxide then do we actually use up? So if you think about it, the ratio of iron 3 sulfate to potassium is 1 to 6, right? So this should be 6 times more. So what's 6 times 0.0038? 0.0228, so we'll say 0.023. Okay, so the ratio of 0.0038 to 0.023 is 1 to 6. Okay, how many moles of potassium sulfate do we need? So look at the ratio of 6 to 3. What is that? 3 is exactly half of what? 6. So that means that this should exactly be half of this. 0.0115. And the ratio of potassium hydroxide to iron 3 hydroxide is 6 to 2, which is exactly 3 to 1. So then this one should be 3 times smaller than this. Divided by 3. So that would be 0.023 divided by 3 is what? 0.00776? Okay. Alright, so now we have the number of moles of each reactant or product. We already know that the limiting reagent was which one? The iron, right? Iron 3 sulfate. How much mass did we use up then for that? So we know that this is 1.5 grams. So now we're going to solve for potassium hydroxide, potassium sulfate, and iron 3 hydroxide. Okay? So, what's the mass of potassium hydroxide that we use up? So the mass is the number of moles times the molar mass. The mass would be 0.023. So molar mass of potassium hydroxide. What do we work that out as? 56? So what's that? 1.28. Okay, let's just round up to 1 decimal place. 1.3 grams. Alright. Potassium sulfate. Okay, so number of moles is 0.015, and the molar mass of potassium sulfate is, so potassium sulfate is 2 potassium, 1 sulfur, and 4 oxygen. So 2 potassium is 39 plus 39 is 78. 1 sulfur is 32, that's 8, that's 110. 110 plus 4 oxygen. 4 oxygen is 64, so that should be about 174. Okay? So what is that? 0.015 times 174. You're right, sorry, it is 0.0115. It's 0.0115, you're right. So 0.0115 times 174 is 2? 2.0 grams? Now, so on the left side we have 1.5 and 1.3, that adds up to 2.8. On the right side we have 2 grams, so that means the remaining must be 0.8. But let's just work it out. Let's just work it out. So number of moles times the molar mass. Alright, we're almost done. Number of moles is 0.076. The molar mass of iron 3 hydroxide. 0.0076. Alright, 0.07. Alright, so iron, so what was iron? 63.55? It's about 64. And hydroxide is 17, and then we have 3 of them, so that's 51. Plus 64 is 115. So what's the mass of that? What's 0.0076 times 115? 0.87. Again, we rounded it off, so it's going to be off a little bit, but that's okay. But that's the big idea. All right, ladies, so that's it. Limiting reactants. The end.